In late September 2024, Hurricane Helene moved across the American Southeast. As the storm pushed into the Appalachian Mountains, it dropped record levels of rain, triggering wide-scale flooding that submerged entire towns. The town of Spruce Pine, North Carolina, sat directly in the path of the flood. The rising water collapsed embankments and destroyed the local utility infrastructure, leaving the region without power or road access. Industrial zones near the river were paralyzed as mud and debris surged through buildings, forcing an immediate halt to all local operations. As news of the damage spread, supply chain analysts and technology firms globally began tracking the status of these specific coordinates with intense scrutiny. A local weather event in the mountains of North Carolina had effectively suspended production at a site linked to the global semiconductor supply chain. The focus was on two specific entities, the Belgian group Sibelco and the Quartz Corp, a joint venture between French and Norwegian mineral firms. Both operate mining and processing facilities in this district. This chart shows why this land matters. Estimates indicate Spruce Pine supplies 70 to 90% of the world's high-purity quartz used in semiconductors. This output is the physical foundation for a global semiconductor market valued at $600 billion. After being processed in Appalachia, this material is shipped to advanced fabrication plants across Asia to be used in the manufacturing of integrated circuits. The entire global processing system, despite its scale, relies on the consistent flow of material from this single mountain range. It is a common misconception that this quartz is a component inside your phone or laptop. In reality, the quartz never enters the finished chip. Its role is as a piece of high-performance manufacturing equipment. It is used to create the raw silicon that eventually becomes a computer chip. Most silicon is produced via the Czochralski process. This requires melting raw polysilicon at 1,414 degrees Celsius, the exact melting point of silicon. The vessel holding that melt, the crucible, must be made of high-purity quartz. It has to withstand extreme, sustained heat without warping, or releasing even a single part per million of trace metal into the liquid silicon. A crystal is grown by pulling it slowly from the melt, forming a cylindrical ingot. That ingot is then sliced into the polished wafers that serve as the base for all modern processors. Because even microscopic contaminants can ruin a production run, a consistent silicon wafer is impossible to manufacture without a high-purity quartz crucible. While quartz is one of the most common minerals in the Earth's crust, the industry cannot simply source it from any mine. The Spruce Pine deposit was formed 380 million years ago during the collision of paleocontinents. The unique geological conditions created a formation with exceptionally low levels of iron, aluminum, and lithium. Purity alone isn't the only factor. The real value lies in the material's processability, the ease with which these specific grains can be separated from impurities during refining. Sibelco and the Quartz Corp use guarded chemical and thermal treatments to purify this ore. Their goal is to achieve contamination levels measured in parts per billion. For a competitor, replacing this supply would require finding an identical geological anomaly and recreating decades of proprietary refining knowledge. In the weeks following Hurricane Helene, the central question for the tech industry was whether the disruption would lead to a global manufacturing halt. A total stoppage was avoided thanks to supply chain buffers. Both the mining companies and the crucible manufacturers maintained stockpiles of material to manage short-term outages. Downstream wafer producers also held enough inventory to keep their fabrication environments operational while the mines were offline. Both Sibelco and the Quartz Corp were able to restart their operations and begin ramping up shipments within a few weeks of the storm. While the 2024 disaster did not trigger a global shortage, it functioned as a stress test, demonstrating how a single region's weather can affect the entire industry. Governments and tech firms are currently seeking alternatives, looking towards synthetic silica and new mining projects in places like Norway, Australia, and China. However, alternative scale is limited. China's 5,000-ton annual production is a fraction of global requirements. Furthermore, qualification poses a barrier. It takes chipmakers years of testing to verify new quartz won't compromise multi-million-dollar production cycles. Consequently, the existing supply remains central. Sibelco is currently investing hundreds of millions of dollars to expand its Spruce Pine operations. The industry managed a short-term pause in 2024, but the concentration of this resource remains, leaving the global economy vulnerable to any future disruption that lasts months instead of weeks.